and welcome to Algebra class at Algewots. I'm Professor Johnson, and today you will be learning about the greatest common factor. Not just any common factor, but the greatest. The greatest common factor is similar to our work with square roots. We want to get out as much as possible that the expression has in common, just like in square roots where you wanted to factor out as large of a perfect square as possible. So, in the greatest common factor, our goal is to look at an expression and take out of the expression the largest thing or term that all of the terms have in common. So, we are going to first look at determining the greatest common factor and then the process of factoring it out. Right, so let's continue. Make sure you are following along closely in your notebooks or with your quill and parchment. First, our first example, feel free to pause and write this down, is to factor 49x cubed minus 7x squared plus 14x. The process of determining your greatest common factor begins with looking at the numbers 49, negative 7, and 14. The largest number that all three of these have in common as a factor would be 7. That is the beginning of our greatest common factor. Then we look at the variables, x to the third, x squared, and x. The largest amount of x's that I could pull out of all three of them is not x cubed, because the second term and third term do not have x squared or x cubed to give. However, all of them have at least one x to give, so that is part of my greatest common factor. I cannot take out x cubed to x squared because the third term does not have more than the x to give. So, the greatest common factor in all three terms, what they all have in common, is 7x. However, this is not the answer. The answer, if I follow the directions of factoring, would be writing this expression in factored form. Now that begins with writing the greatest common factor, followed by parentheses. We need to determine what would be left inside the parentheses if I factored out 7x from each of these terms. So I'm trying to think 7x times what value will get me back to 49x cubed. Some of you are able to do this just looking at it. A common way to do this would be to divide each term by the greatest common factor, 7x. When I take 7x out of 49x cubed, 49 divided by 7 is 7. X cubed divided by x leaves me with x squared. Minus, I do it for the second term. 7 divided by 7 is 1. X squared divided by x is x. Plus 14x divided by 7x. The x's cancel, and 14 divided by 7 is 2. This is my factored form. This is the final answer. The answer is not just the greatest common factor alone, but it is the factored form of the expression. You'll notice that this form is equivalent to the initial simplified form, just factored. There are two ways to check if your final answer is correct. First, look in your parentheses. Do those terms have anything else in common? If they have a common number or common amount of variables, then you have not fully factored. 7, 1, and 2 do not have anything in common. X squared and x have an x in common, but 2 has no x to give, so I know I have factored out everything that I can. The second way to check would be by redistributing your greatest common factor. If I distribute 7x back in, I should get back to my original expression, 49x cubed minus 7x squared plus 14x. Since I do, I know that I have the correct final answer of 7x times the quantity of 7x squared minus x plus 2. We're going to try two more examples. Feel free to pause, write this down, or skip ahead if necessary. Number 2, factor 30c to the 5th minus 20c cubed. I look at the numbers first. 30 and 20 have 5 in common, but they also have a larger number, 10. So 10 is the greatest common numerical factor. Now we look at the variables, c to the 5th and c to the 3rd. The most c's I can take out is c to the 3rd. Now, 10c to the 3rd times what gets me back to my original expression? Well, I can divide each of these by 10c to the 3rd and see that 3c squared minus 2 is what's left inside the parentheses. Again, that's by dividing the greatest common factor from each term. I look in the parentheses and make sure that you have nothing else in common, 3c squared minus 2. And then I can also multiply 10c cubed back in to make sure I get back to my original expression. This is the factored form of this expression. The greatest common factor is 10c cubed, but again, the entire thing as a whole is the factored form. Right, we're going to do number 3 now, and actually we have one more after this, so I'm sorry, I lied earlier, there are 2 more problems. Factor 44y cubed minus 11y. Between 44 and 11, the common factor is only 11, so that will be part of my greatest common factor. In y cubed and y, the most I can take out is just a single y. This is now my greatest common factor. But again, I need to make sure I figure out what's left to get my entire factored form. So when I divide each of these by 11y, I'm left with 4y squared minus, and you'll notice here that the 11's cancel and the y's cancel. This is not a 0. We need to make sure that they divide to 1. When you're canceling out, they're dividing to the number 1. So my final answer in factored form is 11y times the quantity of 4y squared minus 1. And for our last problem, we are asked to factor 13x to the 6th minus 7y squared. First, I look for a GCF. 13 and 7 numerically have nothing in common. Then I look at x to the 6th and y to the 2nd. They have nothing in common. At this point, I cannot factor out any greatest common factor other than the number 1. Now, it would be silly to factor out to 1 because I'm left with the exact same expression. There is no point in writing it this way. So we would say that this problem is already in factored form. There you have it for today's lesson at Algebraics on the greatest common factor. Now you will go to Dueling Club and practice your new skills.